Hello, hello. We are team number 16. I'm Evis Reyes. Our group members are Jorge Larrarte, Jose Arraut, and Alejandro Infante. Today we're going to give a presentation from our modeling of robot class. This presentation is divided in two main parts. You can see in the PowerPoint, this is the first part of our presentation. Basically, we're going to study and analyze slider crank mechanisms. As you can see at the bottom, slider crank convert rotary motion into the linear motion. Basically, we're going to explain how do we find the position, velocity, and acceleration of this slider crank mechanism. Also, we're going to study the trajectory of the copper link, and we're going to compare the result between two possible closures. For the second part, we're going to synthesize the four-bar mechanisms using the three given positions of the copper link. We're going to explain how do we find the position, velocity, and acceleration using the questions given in class. Also, we're going to explain how we design, analyze, and animate the four-bar mechanisms. Now, Jorge Larrarte is going to explain more about our project. Thank you.
Okay. Here are the calculations for project number 1. As you can see in the table up there, those are the data given in the project. As you can see, the input was at angle theta 2 with an angular velocity of 3 radians per second and an angular acceleration of 0 radians per second squared. This is the schematics of the mechanism given. Once you find the position of the slider and the position of the copper link with all these formulas, the next part of the project, it can achieve calculating the position of the trajectory of the point S attached to the copper link. The kinematic analysis, it means like the velocity and the accelerations were relating to the position analysis. So you have to use the length, the length travel and the angular position of the copper link in order to calculate that. In here you can see the comparison between the angular acceleration and the angular velocity and angular acceleration between the two closures of the copper link. Also, you can see like the results are a smooth course, and for the position, the trajectory of the point S, it completes like a circular trajectory. So the goal was achieved. For the second project, the data given were 3 points of the copper link, point A and point B, 3 different positions. Those positions were used to find the pole positions, and these pole positions were proven like calculating the radius of the length, in this case, between each pole and between the poles and each coordinates. Once we prove that and calculate the length of the links, we encountered some problems doing the position analysis, because we were taking an imaginary root, imaginary number when we perform the square root in this formula right here. So we have to perform several calculations and increasing or increasing the value of the first position given. For the position analysis, we perform the same steps, but in this case, were for four-bar mechanism. Now, here is you can see the plot of the 3 positions given and the comparison between the angular velocity and acceleration of the copper link. Jose is going to talk about the SolidWorks.
Okay, well, here is the SolidWorks part. Here we have the design and animation of the mechanism. Here, this is the actual mechanism for a slider crank. Here we have, well, we built this based on all the values given in the problem statement. Here we have the link 1, here we have link 2, here is the block where the slider goes, and here is the slider. And our input is right here, and it's going to be data 2. As you can see here, you can see the movement of the slider, and where this link rotates from 0 to 360 degrees. Now, the design and animation of the mechanism in real life application. There are some a lot of applications that are made with a slider crank in a real life, but the one that we use was something very simple that is in your car. This is the internal combustion engine. As you can see here, the piston is going to simulate the slider, and the crank is going to simulate the other link. And here it will be the input. With this motion right here, you can see how it rotates around its own axis. And here you can see the slider where it goes and come back. That's for the first project. Then for the second project, this is the 4-bar mechanism. This one was built based on the calculation that were made. Here we have the link 1 that is attached to the ground, is fixed. Then we have link 2, link 3, and link 4. And here is the application. This application is basically used for the tractors, for the buckle, when they go and grab the dirt and take it out, or they build holes or something, stuff like that. Here you can see the animation of the real-life examples. As you can see, here is the buckle. When it goes down, pick the dust and put it in the other side. Now we have some conclusions and recommendations for the project with my partner Alexander.
To sum everything up for you, in the first project we initially performed a position and kinematic analysis of a slider crank mechanism. We basically put a point on a coupler link and analyzed its trajectory, and we compared it with the results for all possible closures. In the second project, we obtained the lengths of the links using 3 positions given of a coupler link. We encountered a few errors and were able to overcome them quickly by performing calculations by hand. And all in all, we were able to reinforce all the theories we learned in class. And any recommendations I have for you would be to follow all these calculations, because they're necessary to complete any good robotic design. Thank you.
Thank you.